Chat, what is up? I know you've been missing me in these past 4 months, but we're back again once more for another math problem. Today we've got OMMC 2024 problem number 15. So let's get right into it. So here we have triangle ABC. We're dropping the feet from A onto the two medians, and then we're given three side lengths. Three side lengths are seen right here, and we want to find a fourth side length. So let's see what information we're given. We're given BG, we're given GC, and we're given QG. And what we want to find is GP. So it's kind of like symmetric in that sense. And what this should remind you of is if you had a cyclic quadrilateral, and if you have like a cyclic quadrilateral, let's see right here, cyclic quadrilateral, we draw the two diagonals, we would have like this times this equals that times that. So if quadrilateral BQPC was cyclic, then we'd have BG times GP is equal to CG times GQ. Unfortunately, I mean, if we just look at the thing here, that is not going to be cyclic. I mean, we clearly have not drawn a circle right there. So let's take a step back. I don't think the power of a point is going to work. It, in fact, is not going to work. So we're going to have to deal with something a little bit extra. So let's look at what we have here. We have the foot from A to Q. We have the foot from A to P. So we have these two right angles here, and we know we'd like to use power of a point. I mean, that seems convenient here, right? So what would be a natural thing to do here? If you know a fact about medians, this is very helpful here, is if we drop the foot from B onto the median like this, if you kind of tilt your head sideways so that AB is horizontal now, it may be more apparent that this fact is the case, but we have that these two lengths are actually equal. And the way you prove that, it's very simple. It's just with congruence. Because this is a median, we have like A, let's call this M. AM is equal to MB. And then we also have that there's two right angles right here, and we have these angles are equal. So by, I guess this would be AAS. Yeah, AAS congruence. These two triangles are congruent, so we have that this equals this. And that's helpful because we're given the length. What are we given? We're given GQ. And this, like knowing these lengths are equal helps us a lot, as we'll soon see. So we do the same thing right here. We draw this foot right here. And once again, we will have like, boom, there's not a lot of space here. But yeah, these two lengths are equal. So, I mean, we've added these 2 points. Why would this be helpful? The reason why it's helpful is because now we have a cyclic quadrilateral. So let's call these points Q prime and P prime. And because BQ prime C and BP prime C are right angles, we have that B, Q prime, P prime, C is a cyclic quadrilateral. And that's good because when we have a cyclic quadrilateral, we can use power of a point on the diagonals. So let's once again look back at the information that we were given initially. So we're given that BG is 354. So that's good. That's like one of the parts of a diagonal in the cyclic quadrilateral. And what we really want to find is we're given GQ and we want to find GQ prime. So how are we going to do that? Well, you may recall that in a triangle, the medians cut each other in a 2-to-1 ratio, and that's going to be very helpful here. So since we know that CG is 492, it's going to follow that, okay, I'm going to write it up here. GM is equal to 492 over 2, and that is 246. All right, and we're given that QG is 433. So if we have that QG is 433 and MG is 246, we can find QM now. So QM is going to equal, it's going to equal QG minus GM, and oops, that looks like a 6, minus GM. And the good thing is we know what both of these are. So we have 433 minus GM, which is 246. This is actually kind of difficult. Wait a second, 433, 246, so 3, 6, 7 would carry the 1, 8. That's a 1, right? Yeah, so it should be 187. Wow, this is truly the the pinnacle of this YouTube channel right here. All right, so we know that QM is 187. Why is this helpful? Because now we know what GQ prime is. So what would GQ prime be? GQ prime would be equal to GM minus MQ prime. But we know MQ prime is equal to MQ, so it's just GM minus MQ. And that would be, I think that would be 59. Yeah, hopefully I didn't do this math wrong. I mean, these 3-digit numbers in the geometry problem, that's never a good sign. I mean, you're always going to have to be doing some terrible calculations. So we know that GQ prime is 59. We know that GC is 492. So the power of G with respect to this circle right here should be 59 times, actually I'm going to do it on the left side. The left side is like where we do all our calculations. 59 times GC, which is 492. And that should equal BG, which is 354, times GP prime. And actually, let me just write out the equation without the numbers. Oh crap, I moved the whole thing down. Oh no, okay. Let's try to move it back. Oh, perfect, okay. So now let's write the actual equation. Let me switch colors too to indicate the significance of this equation. So we have GQ prime times GC is equal to GB times GP prime. Oh no, that prime right there did not move with the thing. So let's rewrite it. All right, so we're switching back to blue, and now we can solve for GP prime, which is kind of what we wanted to do. So this is our equation. I think we did do the math right because it looks like 59 divides into 354 cleanly. So let's see, what is G prime equal to? Let's see, GP prime. I keep writing my G's like sixes. GP prime. Let's see, so if we divide both sides by 354, 59 over 354 is 6, and then 492 over 6, that should be like 82. So GP prime equals 82. We're not quite done yet because they actually asked us to find PG. So, okay. But we're on the closing stretch now. GP prime is equal to 82. So, once again, we know if we let this point right here be n, we know that Gn is equal to, what is it? It's going to be Bg over 2, right? So that's 354 over 2, which is equal to 177. All right, so that's GP prime is 82, Gn is 177. And then, well, GP prime, Gn, and GP, those three segments, they form like an arithmetic sequence, right? Because P prime n is equal to NP. Sorry, I realize now the diagram's absolutely atrocious. You can barely see what's happening. But yeah, so it's just going to be an arithmetic sequence. So GP prime, Gn, and then GP. So what's next? 82, 177. This is some kindergarten type stuff. We have 177 plus 95. That is going to be like, oh my God. I think that's 272. All right, that's our answer because that's what we were asked to find. PG or GP, that's equal to 272. Yeah, I have nothing else to say. This is the first time I've not made an inappropriate joke in any of these YouTube videos. So we're on an improvement streak here, just like my mewing streak.